In this lecture, we're going to use a box ray cast to detect enemies. At the moment, we can't apply damage to an enemy until we know who was hit. There are different ways to detect enemies. Previously, we used a spherical range to detect players. However, that solution won't work for our purposes. Characters should only be able to hit what's in front of them. If they're not facing an enemy, the enemy should not receive damage. For this scenario, a ray cast is perfect. In the resource section of this lecture, I provide a link to a class called Physics. Under the list of static methods, there's a method called ray cast. You can think of a ray cast as an invisible laser beam. Unity stores a list of objects hit by the laser beam. In this class, there are two methods called ray cast and ray cast all. They perform the same action. The difference is that the ray cast method returns a single object hit by the laser beam, whereas the ray cast all method returns an array of objects. For our game, we're going to allow players to hit multiple enemies at once. However, we're not going to be using the ray cast all method. The ray cast all method expects the enemies to be in a straight line. Using this method is perfect for projectiles where accuracy is important. In our case, our players will be wielding axes and swords. Accuracy is much more flexible. As long as the enemy is in front of the player, they'll be hit by the weapon. In the same class, search for a method called box cast all. The boxed cast all method will send out an invisible box instead of an invisible line. It'll allow for a broader range of objects to be hit. I think it's perfect for our case. Let's give it a try. In your editor, open the combat file. Scroll to the handle bubble hit method. In this method, replace the print statement with the physics.boxcastAll method. This method accepts 5 values. The first value is the center of the box. Let's pass in the following: transform.position plus transform.forward. The box should start at the front of the player. At the same time, we don't want the box to hit the player. Otherwise, the player may damage themselves. The center of the box should be positioned in front of the player. We can position it at this location by taking the current location and adding the forward position. The next value is half the size of the box. Let's pass in the transform.localScale variable. This variable contains the size of the current game object. I think the box should be the same size as the player. However, I mentioned this parameter accepts half the size of the box, not the full size. So, let's divide this variable by 2. After passing in the size, we can pass in the direction of the box. Where should the box travel to? Let's pass in the forward position by passing in the transform.forward variable. The transform component contains the direction of the blue arrow in a variable called forward. Next, we must provide the rotation of the box. I think the box should have the same rotation as the current character. Let's pass in the transform.rotation variable, which stores the current rotation. Lastly, we must provide the distance of the box. How far should the box travel? Let's set this value to 1f. The box will travel for 1 unit. It shouldn't have to travel far. The box cast is finished. The last thing we need to do is store the results. If we hover our mouse over the method, we are given the type of the return value. According to Visual Studio Code, it's called ray cast hit. Most importantly, it's an array of values. If the type has a pair of square brackets, this information means the value is an array. Let's store the return value in an array called targets. Add the ray cast hit type with a pair of square brackets. Perfect. In the next lecture, let's begin looping through the results.